Okay, good deal. I'm going to be covering people that have heard me before. I talk about this business system. That's what I'm really big on. I just got back from a CFO conference where I spoke earlier this week on that. So that got real good receptance, on how you go in and look at metrics and how you integrate strategy and improvement efforts of the business as a whole. However, this time I'm going to be talking about something that's a little bit different. I'm going to be talking about what I call multidimensional testing, but I'm going to tie it also to the business system integration. So these are the objectives that I'm going to be having for this particular session here. We're going to talk about what I call pass-fail functional testing, or I can call it multidimensional testing. And if we're going to then go in and describe how a simple situation on how that you might be able to apply these techniques. Now, if we look at a response that we might have in an organization, we've got a continuous and attribute. You guys are quite familiar with those, right? Okay. But I'm going to be talking primarily about what I call logic pass-fail situation. So if you look at a continuous response and you have a part that you're measuring the dimension on it, you get a micrometer or some other device to measure the overall length of it. Or, for example, if you're looking at how long it takes to do something, it's a continuous response. Now, an attribute response would be, for example, if you were loading 1,000 sheets of paper device and you looked at what percentage of them failed. So you put a sheet of paper through it, it either passed or failed. Or you went in and tested something and it either passes or fails. There's no ifs, ands, or buts about it, but sometimes it works, sometimes it doesn't work. Now, that's not what I'm going to be talking about tonight. I'm going to be talking about what I call logic pass-fail situation. So in other words, if you run a certain set of configurations or situations, it always fails. That's where the word logic comes to. Okay, so for example, you've got a computer system. I know you've never had problems like this. Whenever you do certain things, the thing just doesn't work, right? Okay, well, so that's kind of a logic pass-fail situation. So now the question is, how do we go in and efficiently test for those kind of situations? Because you get in the computer industry or the chip industry, there could be a huge number of scenarios that you might test. So I'm going to look at efficient strategies to go in and test to determine if you've got these logic pass-fail problems for your particular design. So it's primarily set up for testing out a product design. However, you can use it for other situations also. So let's look at a situation where we have a network, and it could have type X versus Y. It could have small versus large memory, and so on. Okay? So we're looking at just the extremes for right now. Now the idea is we want to make sure our product works in all these different combinations that you might have. So, for example here, we're trying to efficiently detect that we got a network type Y is small, and there's a modem. Does it really work? Now, some of the examples that I'm illustrating here are somewhat antiquated, because this is in my book that came out in 2003, and originally I had this described in my first book that came out in 92. So some of the situations or the computer configurations are not realistic in today's age, but hopefully you'll forgive me for that. So to illustrate, our test matrix, there's another possible failure scenario is that occurs whenever there's is number 2 in the first row, so that would be here, okay? Number 1 in the second row, there, number 1 there, and number 1 in the 7th row. So the idea is we want to make sure that those type of scenarios run. Now, if you go in and just tell a test group that we want to test this particular product, they can have many different ways of approaching the problem. Sometimes the strategy is somewhat haphazard. If a failure is detected in this particular situation, they often don't know what happened. They just start testing a bunch of different things. Sometimes you can have test groups that really have a rather complex algorithm on how they're actually going to do their testing. Another group may just do a one-at-a-time approach. Now, if you look at how organizations often test for this sort of situation, they pretty much leave it up to the test group on how they're going to approach it. They don't typically or often have a system for actually testing these type of scenarios. And another one might be a lengthy all combinations test, which if you've got a lot of factors and levels, that could be somewhat impossible to actually achieve. Now, when you step back and look at these scenarios for testing, and generally, we do not have an easy approach with general application. So somebody may do one thing over here, and another person may be doing something over in another situation. Also, there tends to be no stopping rules. We quit when we're done with the test. They gave us 3 months to do the test, 2 months, or whatever. And whenever we get time that runs out, we're done. And that includes regression testing. If we find a problem, we have to redo something. Just whenever we get done with the test, we have to let it go. Because often what happens, you feel like a gnat trying to stop a steamroller. You're saying, well, I got to test a few more things. Also, we typically don't have a good handle about test coverage. How good a job, basically, do we actually do? So what we'd like to do is create an efficient approach to structurally, and I'm big on structure, that could be explained and used by others. So it's a generic type approach that could be applied to various different situations. Now, if you start looking at what we're really applying here, this is somewhat of a control mechanism within the overall development process. So let's look at how we might approach this. Well, what I'm going to do is I'm going to use the design of experiment matrix to actually help me figure out what those configurations are. Now, if you're familiar with design of experiments, this is not the traditional way to do design of experiments. Because if you do a design of experiments, you might have 7 factors across the top, and each one with a high and low value. And you do various combinations of those, and you'll get a response. The answer is 7, 6, 5, 9, or whatever. And if you're looking for factor significance, you're fundamentally going to be averaging the high values, comparing that to the low values, and looking at that difference, and then you're going to make significant statements. But the difference is, we're not doing that in this particular situation. We want them to all work. Okay, so if it works for this particular set of configuration settings, then we're making the presumption it always works. So we'll rigorously test it for this scenario. Now, with the approach that I'm going to be suggesting, we can very efficiently detect whether a problem exists. However, if a trial fails, we really don't know why it failed. Because there's so many reasons that trial number 2 failed. Everything else worked, but we could go in and do a technical assessment often to see what the real problem is. So if you get the right people in there, then they might be able to figure out what the problem is. Because right now, you're taking the role of a test group within a development process. And so you don't necessarily know the ins and outs of the design itself, but if you describe what happened, then somebody from development might be able to figure it out. Now, if they can't figure it out, I do have algorithms and methodologies where you can do a search pattern. So now you can run some additional trials to try to help you figure out what the particular problem is. Now, if you went in and ran this test and you had no failures, which is what's supposed to happen when you get into a test group, the next question is, what percentage of coverage did you actually do? How good a job did you fundamentally do? Now, I'm going to be looking at test coverage different than most people. If you go in